It is common to predict preliminary gravity loads on columns based on tributary length. In structures with simply supported spans, half the load flows to each side. If we have an inside column, we add the loads coming from both sides. This means for relatively ordinary structures, inside columns carry twice the load. Surprisingly, when the inside columns move, their load does not change since they will still end up carrying half the total load. The load distribution is more complex when the span is continuous. This makes the structure indeterminate, and distribution of the load will depend on the relative stiffness of the elements. If the beams are much softer than the columns in bending, the distribution is similar to a simply supported case. The beams will not be able to rotate the outside columns, which is analogous to a symmetric fixed beam. If the columns are soft and the beams are stiff, then the beams rotate the columns, effectively simulating a fixed pinned scenario where most of the load is transferred to the continuous or fixed end of the beam. Both these scenarios assume the columns are much stiffer axially than the beams are in bending. If we simulated axially softer columns, the beam will behave as if it is infinitely rigid, essentially forcing the same length change on all columns. Interestingly, this scenario leads to practically equal loads for all three columns. Clearly, tributary length-based load distribution for columns is valid only under certain conditions, and we must understand the behavior of our structure before we can assume a certain load path.